All right, we've got a whole variety of stuff today. What I wrote down is that we would look at the Rook 2020. So I've got some pieces gathered up that we'll look at. None of it's a symbol, really. So we'll look at the pieces of what we're going to do. I've got the printer running. I'm using a different slicer, one that I haven't used before, the Orca slicer. It's an open source one. It's relatively new. I don't know exactly how old it's been out there, but it's based on Prusa Slicer and Bamboo Labs Slicer. And it's got some kind of neat features, and so we'll look at that. I have used it for about an hour now, so I don't know much about it other than how it overlaps the other slicers that I do know something about. But it does have some interesting features. That's what I'm printing right now. Is it has some built-in calibration tests that seem nice. We'll look and see how they go. Got a couple of parts over here we can look at. The PEO magnetic sheet came in, so we'll look at how that's what I'm printing on right now. In fact, I did get one that's a little bit too small, so we'll look and see. Here's where it's going over here. It looks like it's close-ish to finish. It's doing a flow rate test right now, so not a max volumetric flow test, although it does have a built-in setup for that too. This is a flow rate test, so like your extrusion multiplier or flow rate modifier in Cura, or well, Prusa Slicer or Cura. So that's what it's doing right now. Let's see. Let's start with just looking at some stuff. So since we're looking at this is the PEO sheet. You can see it's a little bit small. I don't remember if I could have gotten a larger one. Let me check real quick and see if I could have gotten a larger one. Where did it go? Yeah, so here, just share this screen. Here's what I got. I could have gone with the 235 by 235, paid another $1 and gotten it to where it fills the entire bed. For some reason I did 220. 220 is more like the printable area of a Ender 3, you know, unless you print right up to the edges. But 235 would have fit on there perfectly. So I should have gotten that one, but I did the 220. And I did the smooth PEO, so that's this side. And then the other side of it is the textured, you know, PEI. So this side, it's not split half and half like this. You can tell that it's flipped one side to the other. So right now I've got it printing on the PEO side, which has been doing well. I haven't had any prints come loose from it. The interesting, I don't know how long it's going to hold up. I have printed 1, 2, 3. This is the 4th print on it of parts. So I haven't printed on it that long. But the interesting thing about it, I don't know if you'll be able to see on camera or not, but we'll try. This is a little token holder, and this is one of the reasons. Let's get down here. One of the reasons that I was doing some of the calibration tests. So let's see if I can focus on it. Maybe ish. If I get too close, it's not going to focus well at all. But I need to be close. First of all, you can probably see, let's get some more light on there. You can probably see the roughness around the edges. That's over extrusion. So I can tell that I'm extruding a little too much here. And then here, the gaps, oh, you can see, look at that. The gaps are, they're one of two things, and well, for me, they are my pressure advance on Clipper is set too aggressively, and it's leaving. This is the Z seam basically, so it's leaving gaps. You know, it's advancing too much, overcompensating. Remember, pressure advance, linear advance, and in a different way, coasting. So coasting is an option in Cura. Pressure advance and linear advance are dealt with in the board of your printer. So Clipper or your Marlin 2.0 can do the linear advance, maybe. But what it's trying to do is it's trying to account for the fact that there's built up pressure in the system. So if your Bowden tube, now we're on direct drive here, so I don't have a lot of built up pressure, but when you go to change a layer, you know, you have that momentary, super tiny amount of time pause where it has to end one layer and start another one, you can get blobs. And so mine is overcompensating, and instead of getting blobs, I'm getting gaps. You can see some holes in there. I wish it would focus better though. Just can't make it focus on it. We'll just have to move back further. So those two things I need to adjust. Pressure advance is too high. If you're not using pressure advance, but you're using Cura and you have coasting turned on, it tries to do the same thing, but on the pre-processing side. So when it's writing the G code, it tries to do that. And so you can, maybe your printer is not running Clipper, or it's not capable of doing linear advance, then you can try to do coasting, which is, like I say, it's doing the same thing. It's just doing it before the file is sent to the printer at all. And so you can go through the same kind of tunings, and it will try to eliminate those blobs on your Z-seam. But too much of it, you get holes. So that's what I've got. The PEO sheet, you can see what it does. So you can see that bottom pattern on there. That's from the pattern of this. So this is kind of a micro etched pattern. Like if you touch it, you can feel little super tiny grooves in there. So I don't know how long they will last, or I'm sure that at some point I'll scratch it. But it creates these cool effects. I printed another one in yellow. Doesn't show up as much. You might be able to pick it up just barely. Even in person, it's not very strong on the brighter color. On the darker colors, it picks up a lot better. So if you're making something where the part that's going to touch the bed is visible, it's a cool effect. Obviously, it only transfers to that side, so it's going to be a one-sided thing. You know, I don't have that pattern on the walls or anything like that. But now these don't make sense because they're going to sit down on the table. But if you had a box or something and the box lid, you could print the lid facing down and then have that pattern on it. So it's kind of neat. It's seeming to stick fine. I have not tried PETG. This is just PLA. Actually, this is an interesting PLA. This is from Graft Milk. They don't exist anymore. They had to shut down during the shipping issues. So whenever shipping had gotten so ridiculously expensive, they had to shut down during then. And they haven't started back up. I don't know if they ever will or not. But they were making some really neat colors and finishes of filament. Cost a little more. Came in this round cardboard box. It was a cool thing. I only have one roll of it, and I guess you can't get any more unless you find them on eBay now or something, or if they start back up at some point. But that's what this filament is. But it's just PLA, and it held on to the bed fine. Sometimes you have to be careful with PETG on surfaces. So PETG can grab too much. So I have not seen any information about printing PETG on the PEO. And in fact, I'm reading over here right now. Let's see over here. And PEO build surface only so this is translated oddly, but only print PLA on the PEO. And that's probably true. I bet the PETG will bond too strongly to it. Some people don't even like printing PETG on PEI. They claim that it bonds too much, although I haven't had that problem before. But the PEO, I would stick to only PLA on there unless you do a little tiny test area somewhere and it works out. But other filaments can grab too much to some of these surfaces, and so they're recommending for sure don't do anything other than PLA, and that's all that I've done, and it's worked fine. So that's that. What I'm printing right now, all these also have the little pattern on them. These are the built-in calibration flow rate chips for the Orca slicer. And again, Orca slicer, let's look at it. Let me pull it up. This is it. So this obviously looks like Clipper's fluid interface, which it is, but one cool thing about Orca slicer is that this is the slicer, but it also will pull in your Clipper interface too. Other, Cura can send stuff directly to Clipper. Prusa Slicer can send stuff directly to Clipper, so it's not that different. But instead of having a separate web page, I do have the Clipper interface or the fluid interface for Clipper directly in the slicer. So that's interesting. But here, it's what I'm printing now. This is pass 2. So the way these things work, let's look at them, is built into this calibration. So let's see, yeah, up here at the top, calibration, they have all of these along with tutorials on different calibrations. I did pass 1. That's the ones I showed you. They were off of the bed. Go ahead, no. Discard. So here's the first one I did. And not only is it built in the geometry, but each one of these little chips gets printed at a different flow rate. So the 0 one is just whatever your default flow rate is, and then it's minus 5%, up 5%, and so forth. I assume they're percents. I think they're percents. And you look at them after they're printed, and whichever one looks the best, you take that. So it turned out mine looked like minus 20 was best. That seems a bit extreme, but I'm going with it for now. It was not perfect, but it was the better of the ones I had. So I went with minus 20. I modified according to the tutorial. Let's see, I still have it up. Pull it in. So, here's a sample where minus 5, or yeah, plus 5 actually looks best. And then there's a little equation down here based on your current flow rate. Mine was currently 0.98. And then you put in which of these is the better one, and you get a new flow rate, which mine dropped down to like 0.78. So it was like 78, 79%. Now I'm currently printing this set, although, yeah, it's printing. It's getting close to done. And based on that, so it's fine-tuning it. These are in steps of 5%, 5, 10, 15, 20, and so forth, and minus 5 to minus 20. These are in steps of 1. So I will go back to the picture or look at these over here and see which one of these is best and modify the flow rate. Again, this is the flow rate, not the maximum flow that we were looking at with the little blobs that we were extruding. Now this one does have a maximum volumetric flow rate test that's a little different too, and we might try that one out. I don't know how long it'll take to print, but this is similar at the very beginning of the quarter when we did just the one-walled box and measured the wall thickness and calculated the flow rate from that. This is another way to do that. This is probably a little bit better than doing the one-wall box flow rate test, although that one's way faster. But this one gives you a little bit more thoroughness on all of these steps that include walls and infill, well, no infill, but top solid layers and bottom layers. And so you get a little better picture of what's going on. And so we're going to look for the one that's going to have the best surface finish once this is done. Let's see how far along it is. 74%. They all look very similar. The others, well, I'll show you some of the others because they did not look similar. So here's the minus 20. So you can tell that it is, well, I don't know if you can tell or not because it's so tiny, but it's under extruded, but compared to some of these others, very lumpy. I don't even know if you can see that. Very lumpy. Almost all the others were like this. There was one that was not horrible. This one, the minus 15, it might have been a better choice to go with than the minus 20. The minus 20 is really under, but it did say if there were two that were similar, go with the stronger effect. So that's what I did. So we'll look and see how this goes on my next set here. Although these are looking mostly under extruded. So I must be somewhere between minus 15 and minus 20. Or maybe Where's -5? -10. Can't really tell. It's I think that's it. Maybe I'm between -15 and -10. Maybe I should have gone to those two, because -20 is a lot. This one's over extruded to -10. This one's actually kind of close. Oh, it's also over extruded a little bit here, but the -20 looks nice, except that it's under extruded. You've got gaps in the top layer, and obviously gaps around the 20 itself. That there's a lot in there. So I went with those. We'll see what this next set says, but it's just kind of a interesting slicer. This is let's look at the actual slicer part of it. So it has several printers built in. So I'm on a my Clipper 0.6 nozzle, because I'm running Clipper and I've got a 0.6 millimeter nozzle in here. You can edit. You want to turn, if you don't turn on advanced, you don't have many things you can edit at all. So turn on advanced, and you've got your printable area, printable height. Actually, my printable area should be reduced. That's not the printable area. So let's make that smaller. Let's go to 225. Origin is at 00. There we go. So that way I won't accidentally send something off the edge of the printer. That does remind me though, one thing you can do in your slicer, if you've got a whole set of parts, like it's going to take multiple platters of parts, and you want to get a ballpark estimate on how long it's going to take to print the whole set, make you a fake printer that is gigantic. So, 2000 by 2000. Well, this slicer won't let you go that large, but others will. They don't care. Cura will let you build whatever size you want. Prusa Slicer will let you build whatever size you want. And then just drop all those parts onto that, auto arrange, and slice it with whatever settings you plan to use. And it'll give you a ballpark idea of the combined total for printing all of those parts on multiple platters at a time. So to give you an idea, it won't be exact, but it'll give you hours of, within hours, maybe even within minutes. Okay, so we can set these. It does have some G-code that you can add, the start and end G-code. With Clipper, most of this start and end G-code is just going to be this, start print and end print. And you put those, we'll look at those in a second, you put those routines into the Clipper printer configuration file. That way, let's say you have a file that you print, you sliced it once and you print it over and over again. You have an Etsy shop or whatever, and you print the same thing over and over again. Then if you need to change something about it, maybe you change the color and you have to do a slightly different flow rate or whatever. Actually, you would do that a little bit differently in this slicer, and in Prusa Slicer. But you want to change something of the start and end code. If the start and end code is in the printer config in Clipper, then you can change it over there without having to reslice stuff. So that's kind of handy. And my start and end are very simple. Let's see, these are our maximum speed limits, basically. They're set really pretty high. I'm not going to print 500 millimeters per second on this little bed slinger. My acceleration is never going to get up to 20,000 millimeters per second squared. I think it would just probably tear it apart if it could even do that. So these are just the upper limits. Extruder, that's where I had to change the nozzle diameter. It didn't have a 0.6 millimeter nozzle by default, so I had to change it to here. I put in some limits. I just did my 25% and 75% of my nozzle diameter as my minimum and maximum layer heights. Those are just general guidelines. You could probably drop it down beyond those, or beyond, or increase it beyond those. And retraction, I've got pretty small because I've got a direct drive. And then retraction speed, I think this might be a little bit low, but there is a retraction calibration test that we can do also. And we save it, and we've got a printer ready to go. Then you've got Oh, I was not showing you my screen. I was just talking through. Sorry about that. I was talking through this. So here's these little tabs. So that's all I was going through. And this is the only thing I actually changed. Is I changed this to 225 because it was set to 250. All right. And then there's that start print and end print. That's the start and end G code. There are a couple other things in here. It's grabbing the bed temperature and nozzle temperature for the start layer. It's grabbing those also. That was already built in there. Actually, I did change one thing here. They had print underscore start, and my startups were called start underscore print. So I changed it to to match mine. So if you look at if you're doing Clipper, and we're almost done, and we look at your configuration, you can write all of these little G code macros to do all sorts of different things, and then call them like they're like little subroutines. And here's mine. Here's my start. It's just G28, which is home. And there's my end, which is home X and Y, which it's just doing now. And I don't want to home Z because it could crash into the parts that are on the plate, so I just home X and Y. And then turn off the heaters, let it cool down. And then M84, I guess I could put a little note in there. Turn off motors, steppers. Oops, not steepers. Steppers. We can save that. That way I can remember that M84 is to turn off the stepper motor so I can manually move things around if I want to. So it printed. Let's go over there and see what it did. So since I did that M84, I can move this manual. Oh, it's really hot. So, yeah, I think I should have done this with a 15 because they're all not bad, but they're all under extruded. See if I can get some of you can tell on this one. See how the top layer is not going all the way to the edge. I have little perforation gaps around everywhere, and on the one here there's some gaps. It's hard to tell on the camera. So what I need to do is, since these are all negatives, then I need to go to the 15, which now that I think about it, they said the larger, go with the larger. I was thinking absolute value, but negative 15 is larger than negative 20. I wasn't thinking about that. So I should have done negative 15. But this stuff, it releases kind of like normal. And when it cools down, you do a little flex and it comes off of there. So I guess we can reprint these with a negative 15 baseline and see what we get from there. Or maybe even a negative 10. So let's see. So this is the original test. 15, it does look over extruded here. I do have tiny little gaps around there. I don't know, the negative 10 is definitely over extruded. I might want to be between these two. So let's go with negative 10. So how you do that is like this. So let's go to our little formula. So here's our formula here. Let's go back to my original flow rate, which was 0.98. And multiply times 100. And I'm going to go with the... I'm going to go with the minus 10. So 100 minus 10. Where they have the plus 5. That was their better one. And then divide that by 100 to get it back into a percent. So 0.882, which is more realistic. So what we will do then is in this slicer, you have per filament. So I've just got generic PLA. Per filament, you have each filament's flow rate because different filaments are going to flow differently. Remember last week or maybe a week ago before that, I don't remember, but relatively recently we talked about the additives that were used to colorize the base raw filament, and they are different. So you add titanium dioxide to make whites, and you add ultramarine to make blues, and all these different. Are they all minerals? No, they're not. You add these colorants, and they all have different properties. They're different size molecules or different stuff. Some of them are organic. I think more of the blues are. I don't remember which colors are organic. Some of them are organic. Some of them are not. And so they're gonna flow differently. So they decided in this slicer, and Prusa Slicer does this also. We just haven't used Prusa a lot in this class. They decided that, all right, you pick your generic PLA. You could even name this as PLA Graft Milk Navy Blue or whatever the color is here. And each color could have its own flow rate. So I'm going to go to 0.882. Now, if you're just printing for a hobby, probably just put a 0.98 in here and print. And most everything will be fine that way for PLA anyway. But if you're printing for any sort of performance or quantity, so you're trying to get the best possible performance, or you're printing something for, you're selling it on Etsy, or you're manufacturing these things at scale, or any kind of scale, then that's when you would go and do more of the tuning per filament, color, and type, because you're going to do the same thing over and over and over again. So I'm going to go with this 0.882, and we will save that so that it saves that in there. We'll save it as generic PLA. And then we will go to calibrate flow rate pass 2. No, I don't want to save it. And I'm going to discard those changes. And there's the part 2. I'm going to slice the plate with the settings that I have over here. And then I'm going to print. And it's going to send it straight to the printer. It's going to take 31 minutes. So we'll have to talk about some other stuff while it's doing. And then I could go over here to this tab and monitor. Oh yeah, it received the file. There's a little preview of it. It's heating the bed, and it's going to go off with the printing. So the Orca Slicer is pretty nice. Let me show you how to get the Orca Slicer. Let's see. I put it here. So obico.io blog Orca Slicer talks about it, and it has a link to it. So where did I find the link? Orca Slicer releases. So it's a GitHub page. It doesn't actually even install. You just download it as a zip file, and it's got the executable inside the zip file. So if we go to releases here, then it's going to take me to their Soft Fever / Orca Slicer releases. And this was May 28th, so relatively recently. And you've got the version 1.6.3, which is marked as the latest release currently. And you've got a couple of different, you got Linux, you got Mac, and you've got Win64. I think it did mention somewhere that you cannot run the the parallels. It doesn't work in parallels. So if you have a Mac and you're running Windows, but they have a Mac version now. So I just downloaded this. It opens, it's a zip file, you extract it, and inside there is the executable, and you just run it. So that's also kind of nice. You don't have to install anything. So it's relatively easy to get and deal with. And I was just looking at what the new features were. Infill inkers. So making sure your infill is attached to your inner wall. Let's go back to our thing. Now we're heating the nozzle. It did, and I'm going to try this out. I haven't done this much, but it did have on the filaments a really hot first layer, 220. That it seems to be working really well though. So that first layer might be a little bit overflowed a little bit because it's so hot for PLA, but it works and looks nice. So I'm going to go with that. So you can kind of see in the PLA, I think it was, yeah. So it also had 220 for the other layers. I did drop those down to 205 where I normally print. Although this printer does have a steel nozzle, so I might need to print a little bit hotter than I normally would to get the same effect as printing 205 with a brass nozzle. So I might go back up to it, but it's working fine now, so I'm not going to change it. All right, so that's going to do its thing for a little bit, and let's look at other pieces that I've got over here. Okay, so I've got all these little, let's go down here. Got all these little things that I've printed now. They're working good. These are resin prints. So they are a mixture of the dregs of different bottles of resin that I have. One of them is a ABS-like resin, so it's got some flexibility to it. Not flexible. There are flexible resins. This is not one of those, but it's got a little bit more durability, and just the regular rigid resin. And since they are liquid resins, you can mix them together as long as they cure or harden at the same wavelength of light, UV light, 405 nanometers, which these all do. Then you can mix them together and you get a kind of a mixture of the properties. Plus, you can add colorant, not the same kind that we would add for the filament, but liquid dyes basically. And so these were colored green because the base materials were, I don't remember what they were. One of them was kind of a gray and the other one I don't remember. But they printed pretty well. The little purple base is FDM printed. I wanted, since they have to stand or they have to like snap onto these bases, I wanted the base to not be as brittle as resin would be. So I printed them in some of this Prusa Galaxy, Prusa Mint Galaxy Purple. And that kind of looks good. If I don't ever paint them, they at least kind of go together. But those are just, that's what those are. They're just sitting out there because I had them on the, just got them off the printer. I've shown this before. This is a deburring tool. It's handy for deburring the edges on a, particularly on a FDM print, but maybe on a resin print. Usually resin's kind of brittle though for that. We did get our little scale here that can measure these guys. I'd measured them all. I didn't write it down, but with this range, all but like we could tell, all but the one where it was noticeably skipping, so the 17 millimeters cubed per second at 200, and the one where it was too hot, this one, were the same weight. So they were all, I think it was 0.28 grams maybe. Let's see. Yeah, or 0.29, maybe it's 0.29. Oh, yeah, 0.29 grams. So this little scale, again, I don't have a way to confirm that it is accurate, but it does measure supposedly down to, it was only $10. That's why I'm being hesitant to say it's great, but it does supposedly measure down to hundredths of a gram, and it can tell the difference in these, whether or not they're actually the weight that it says they are. I don't have a way to calibrate it at that level, so I might need to get some masses. This only can go up to 200 grams though, so I can't put much on it to calibrate it. But it can tell the difference in these, so that was good. None of them were kind of maxing out, like I said, kind of this set, so either low flow rate and low temperature, or higher temperatures, I could go to higher flow rates. Those were the best ones. Also, the way they looked was the best. They've all gotten scattered around now, but that we could go into our, I think it's in the filament. Yeah, so we could, based on what filament we were testing, and you know, this little test that we would do here, we could put a max volumetric speed in here. So like you could do in Prusa Slicer, you could put it here with the filament, and it would just never try to print faster than that filament rate, volumetric flow rate would be needed. 12 is certainly within the range. I could probably bump this up to at least 14 and still be safe with even the lower temperature. So maybe we'll do that. Let's go to 14. I don't think we're maxing out any of our speeds anyway with this, but so we could change it per filament. Looks like we've got some print started over here. Over there. I can already tell these are over extruded. This looks okay. That one's a little over, and it hasn't done any of the others yet. But these are certainly over extruded. This one might be our winner. We'll check and see. That's the -8. And we were at 10, so we would subtract off another 8 to minus, well, we would modify our current value by -8%. Let's look at the parts I have gathered for our Rook. So, well, I've shown you these. We have all the printed parts here. This is heater and thermistor. I did run out, so I haven't dyed them because I ran out of the white filament I was using, and the only other one I had was this. And they're not the same. So I don't know that they would dye the same at all. And I had to print this piece, these two pieces that go at the top, so they're at least symmetric. And then this piece, which is mounting the control board, which isn't even really seen. So, I don't know. I might just leave them the way they are. This one kind of gets covered up because it's under the bed. We've got all our pieces. We're going to just go with the hot end that I took off of the printer that we've been using. So this is just the Creality Ender 3 hot end. We'll use that to start with. We have to get a nozzle. It doesn't have one in it right now. We're going to use a standard thermistor. So there are different thermistors. This is one of the glass bead ones. This is the type that would be in your Ender 3 already. If you try to print hotter, so if you want to print super hot 300 plus Celsius degree parts or filament, then you do need to get a different style thermistor. But for what we're doing, this will be great. I think I will use this heater. This is a standard heater. I think a 40-watt heater. There's no way to tell that on here that I know of. I guess you could attempt to measure it, but pretty sure this is just a 40-watt heater. They do make 60-watt heaters, and I was looking on Amazon for one. Let's see. 60-watt 3D printer heater. So they make some 60-watt ones, and I clicked on one of them, and it said I'd already purchased it a year ago. So if I didn't use it on a printer somewhere and I can find it, we'll use the 60-watt. So obviously the difference is the 60-watt is going to heat faster. It's going to draw more power or more current. And I do have to make sure that what I bought was the same voltage of everything else that I'm using, because there are 24 volt and 12 volt, and I'm not sure what I bought. And I'll have to match up what I've bought with what I am using so to make it work the way I want it to. So we're going to use that. Or we'll probably start with this unless I can find the 60-watt and it does match everything else. So we're going to use that. And then we've got these tiny little, it's going to have linear rails on the top. So these are not super fancy, but they are linear rails versus the V-wheels and versus the rods with a cylindrical bearing type of thing. So these are nice. They, I'm certain, make nicer ones than these, but these aren't bad. So we'll use that for our motion system. We've got a pi. Can't read it down in there. Got a pi that we'll use for the clipper, and got a little pi cam that we'll mount somewhere so we can do some time lapse and monitoring, things like that. It's got a super long ribbon cable on it. Maybe I'll find a shorter one, or maybe we need that long, I don't know. I have gone and cut most of the 20 by 20 extrusions. I I need a few more though, so I've got to. I don't have enough to build the entire frame, and maybe I don't have enough for the top. I think actually they're all the same, but I need 2 or 3 or 2 or 4 more pieces. I don't remember. I just need to get those. So this is why it's called the Rook 2020, is because it uses 20 by 20 extrusion. There are other versions that use round rod. We're going to use at least the board from this. I had this already. So it's the Big Tree Tech E3 or Mini E3 version 3. So this would normally be a board that I would drop straight into this printer. But it doesn't really make sense to add it to this printer if this printer is using Clipper. Or well, it's using the Sonic pad, which is using Clipper. Because the board, once you're using Clipper, the board itself doesn't do a whole lot. It doesn't do any of the processing. It just is the motor drivers. So you've got your stepper motor drivers that are getting all their commands and information from the Pi that's in Clipper or whatever is in the Sonic pad. And so you don't really need a higher end board in a printer that's running Clipper. Maybe there might be some reason. So one thing you could, I guess, say is that this does come with a touchscreen here, so you could add the touchscreen. But if you're running Clipper, then you don't really need the touchscreen either. Plus, this one's running the Sonic pad, which is a touchscreen that's bigger, so that doesn't make any sense. So I'm not going to put that board on here. But if you don't have Clipper running, these are a nice little upgrade. They're not terribly expensive. This is Big Tree Tech, and they will upgrade most of the boards that are coming in any of the older Creality printers. The newer stuff is almost comparable, although this is a pretty nice board, and we're going to use it. I don't think there's any reason for us to use the touchscreen on the little other printer that we're building, though, the Rook 2020. So I might end up with extra touchscreen. What else do we have? Let's see. I've got all sorts of hardware, like, you know, T-slot and M3 screws, stuff like that. If you don't have, I don't see it out here, there is a generally good set. The M3s are probably not the ones. Actually, these have, no, these are all M3. Maybe a M3 through 5 set of assorted fasteners is a decent thing to have with 3D printers, because you're always needing a screw that you've dropped or lost, or you're adding something to a rail somewhere and you need the T-slot things. So it's nice to have. They're not terribly expensive to get off of Amazon for an assorted set of screws. I'm just using the stepper motors from an older printer. Not even sure. This one came off of a TiVo printer, or a Tevo. I'm not sure which it is. I don't know if I'll use this one or not, but the steppers are going to be basically these style steppers. I think the only thing I have left to decide and deal with is the bed itself. So I don't have a heated bed. This, you know, certainly we could power a heated bed with this if we wanted to. With this size bed, it's going to only be like 100 millimeters, 120 millimeter bed. So it's not going to be that I can print really large parts. I guess if I wanted to print ABS and enclose this thing, it's not going to be enclosed. Let me show you what it's going to look like. So it's going to look like this little guy. So I suppose you could put some panels and enclose it, sort of. The bottom would be open still. Maybe you could enclose most of the bottom, and the top's just wide open. unless you build something, a little cap for it. So I'm probably not going to be printing ABS, and PLA will work fine on a non-heated bed in most cases. So I'm probably just going to get a little flat sheet of aluminum and water jet it to the right size, punch some holes in it, and mount it on the bed, or mount it on this little triangle which holds the bed. If we want to heat that, I'm sure there's a let's see if we can find something. They make little silicone, here they are right here. So they make little silicone pads that you can just stick onto the bed. This one has a thermistor and heater built in, 24 volt 60 watt heater. It's $19. So, and you can even get the aluminum plate also if you wanted to it, and you could even have a build plate so you can get the whole set here for, well, now you've got 30 and 50 and 60, so 70 something dollars. That starts adding up. But we could heat it relatively easily. The aluminum plate, that's a little high, other than the fact that it's already, if you don't have a way to cut out aluminum already, then you might have to go with that. Oh yeah, the power supply, I'm just using a power supply off of an older printer. I think these Rooks can run off of a like a laptop charger power supply, particularly if you're not also running a heated bed. I think there are some power supplies like that that could run this. I'm not sure what I'll do, but I do have you know, a PC power supply. And then we'll print this little guy right here for our hot end holder, and I will have to source some fans. I probably have some somewhere that we can use for the fans, but it shouldn't take terribly long to build all of this. I have most all of the pieces. We'll see. I have some Gates belts also somewhere over here that are going to drive the motion system. If you notice, I don't know if you can tell or not, but the Z-axis motor is right here with a pulley on it, and there's a idler up here. So the Z-axis is actually belt driven on this one versus a lead screw. So these rods here are guides, but the up and down motion is actually controlled with a belt. So that'll be, I don't have any printers that are controlled that way on the Z-axis, so that'll be interesting to see how that works. So we'll start building on that. I haven't made any feet for it, but we can print some TPU feet. I actually might have some stick-on vibration isolators that we could just stick on there, or we could just set it directly on the feet that are there. But I'll start building this guy and give you updates. We have about 3 weeks left on the quarter, so on the class, and I've noticed that, you know, most people are starting to turn in. I've got several things to grade over here, so I've got a whole list of stuff I need to do for grading. Don't forget about the class project with the, I guess they're on the assignments, aren't they? Or are they up here? I guess I could be in here with the chess set. So I've got a couple of the pieces that have been claimed. I don't know if I've got any new. Oh yeah, there's some pawns that we can put out there, so that's good. We'll get all the pieces. I don't know if anybody's turned in any pieces yet, but that kind of fits with our Rook printer. I'll try and print some of them on the Rook. Maybe we at least print the Rooks on the Rook. I don't know. All right, so let's see. Let's go back to see how our printer's doing. It has at least printed some layers of all of these, and they're generally not looking bad. These up here are kind of under extruded. Can't really see what's going on over here, but it looked originally like this row was over extruded, so we're going to be somewhere in the middle, and it's kind of looking like this -8 is the winner. This one's not far off, but the -7 looks a little over extruded. I can't see the -9 to know what it looks like. But we'll get closer to that soon. Let's see. In fact, how are we on time? It's only halfway done, so I'll let it finish. Probably let it keep going. So the next step that I think I would do is I would go back into our calibration, and I think I would do the pressure advance test, because our holes on our model that we printed here and on several others, so I printed a different color, same holes, and I've noticed it on a few of the other things I've printed where there were gaps. My pressure advance is being too aggressive, so I need to do a pressure advance test and see what we're going to do. So I've got a direct drive. I could do a pressure advance line test. I like that one. And nope, I'm going to change what this one. I might have to look at the tutorial on that, because that's not what it's supposed to print. But maybe it's just giving me a preview of what it's actually going to print. If I slice it, we'll look inside. If I slice, oh yeah, here's what it actually prints. So it actually prints all of these lines. So they look like just straight lines, but if you look up here, this mark and this mark, that's where it's kind of doing a start and stop. And these numbers off to the side are the amount of pressure advance per line. And let's look at the tutorial, because it'll show you. Let's see. Here we go. This is what will happen. So these speed change indicators, you can see here, I have bulges right after this speed change until way down in here, and then I have some like thin sections. And over here, after this speed change, I have some gaps until like maybe here. So like this line right here, one of these two, the like the 016 or the 018 line look best. I think maybe the 016 line looks best. And so you would take that number, and that would be your pressure advance. So it's really straightforward and pretty easy to look at. The thing I like is that for the Orca slicer is that it just does it. You don't have to enter any commands. Since it has direct access to Clipper, it can put the commands to generate the changes that might need to be changed, turn off your existing pressure advance. It can do all of that without you having to do that part. So if you're running Clipper, and it's worth at least looking at the Orca slicer, because it basically slices like Prusa. So it on the prepare side, it looks a lot like Prusa operates. Maybe the icons are different, but it has most all of the features that Prusa has, or maybe all of the features that Prusa has, plus some. And then it directly integrates with your Clipper. It has this nice set of pre-built calibration tools. It's worth, and it's free. So it is free. You don't have to pay for it. So it's kind of nice. I'm liking it so far, but again, I've used it now for 2 hours, so I can't give you a definitive answer. If you're happy with what Cura does and what Prusa Slicer does, then stick with that. You know, you don't have to do any of this stuff to make your printer work. I just try it all out to kind of tell you what I think about it. But I kind of like Orca Slicer so far. It has a good the thing I don't like about Prusa Slicer is that it does all of this stuff minus directly integrate with Clipper and have the calibration tools built into it. But it's just organized in a difficult for me to understand way. So this one, the layout of where settings are found is a little more intuitive for me anyway. So I like that a little bit more. I have not used the Bamboo Slicer, but this is also built on Bamboo Slicer. In fact, I think that's where these calibration tools are from. I don't have a Bamboo printer, but this one is a nice combination of everything. So I might use it for a while and see if I like it. So far I do. Hopefully for next time, so Friday, I'll have collected our photogrammetry data. I think there shouldn't be many reasons I won't be able to do that, but you never know. And we can try to get back into some of the modeling side of things. Plus, I'll have used this Orca Slicer some more and tell you how it's doing. The next one, like I said, the next thing I plan to do is the pressure advance test. It does have a retraction test. Maybe I'll run that. But I want to get into the max flow rate, so the volumetric max flow rate test. It does it differently than what we were doing with the little blobs. It actually does a print. Now, it's a one-wall print, which can not always tell you the whole story, but it's more than just squirting filament out and measuring the mass of it or the weight of it. So we'll see. I'm going to try it out and see what happens. And hopefully I'll also on Friday have at least some of the Rook 2020 assembled so that we can start to see what it's going to look like. All right, I will be back Friday, and keep turning in assignments. And if you have any particular things you want to know about 3D printing wise, let me know so that I can add it to the list of things. We have like maybe 1, 2, 3, 4, 5. We have 6 or so topics left, something in that range. So if there's a thing that we haven't covered, or a thing that we have covered but you want covered more, then let me know so that I can do, or at least try to incorporate some of that stuff, because we're getting close to the end.